Owl AI is a newer company, and we're focused on thermal computer vision. So what that means is we use thermal imaging and our computer vision software in order to project new safety systems, new ways to visualize scenes outside in complete darkness or bright blinding light. So it's a new modality that we're bringing into the automotive industry. One of the big things is, while thermal has actually been around in the industry for a long time, it's predominantly been used in defense applications, or has been viewed as a very high-end luxury item for something called night vision. But it has never really been tied into pedestrian automatic braking for nighttime driver assistance systems. So what we're really trying to do at this show is to highlight what does thermal imaging look like and how does it compare to other camera modalities that use visible light. So everybody's familiar with RGB cameras that are being shown all the time, that are used in a lot of pedestrian applications, emergency braking applications, but we're trying to show thermal imaging and how it works. So we have a demonstration here that I'll briefly show you that shows how thermal compares to a visible light camera. What we're showing here is a multi-scene view. On the bottom left is just a thermal image. Thermal always comes across as grayscale. It's a series of black and white colors. And what you see up here is we're showing the scene out looking into the trade show floor here. And then what we do is we take these raw thermal images and we do what's called object classification, and we add ranging information on top of this. So we're running our neural network software where we're classifying an object, we're doing what's called segmentation on that object, and then we're adding additional ranging information so we know what the distance is. And that's really important for when you're doing pedestrian emergency braking, is you want to classify what an object is, and then you want to know how far it is away from your vehicle. But you want to be able to do this in dark conditions when there's absolutely no light, or you want to do it in understand how this, where this information is coming from when it's also very bright outside, coming out of a tunnel. And regular RGB cameras just don't see at night, and we're showing how that works. What we think of today when we think of autonomous driving or level 2+ ADAS assistance systems, vehicles have a series of sensors that are used. And if we walk through those sensors really briefly, there's cameras that are using visible light, as we talked about, RGB cameras they're talked about, and they're surrounding the entire vehicle, and people have been using that for a long time to do object classification. In order to get detection and ranging, people have started to use radar for many, many years in a vehicle, but to get even more points on target, to get more fidelity, radar has also been augmented by LiDAR. Both radar and LiDAR are used to detect an object, but they don't know what it is. They don't know if it's a person, place, or a thing. They just know it's out there. So again, cameras are used for visualization. Detection is the domain of radar and LiDAR. Thermal is a form of camera. Okay, so it's a vision system. So it too, like a regular camera, can do object classification. But the difference is we run off a different wavelength. We're a passive technology, so where a camera needs to see light photons coming in order to give it scene information, if turn off the lights, a completely dark room, there's no light, so a camera just doesn't work. Imagine driving down a road at night and a deer pops out outside of the field of view of the headlights, or there's no other active illumination like moonlight, you just don't see that deer. We run off at thermal imaging, we run on a very different wavelength. We run on the long wave infrared spectrum, which is approximately 8,000 nanometers to 14,000 nanometers. So we work off of something called thermoelectric energy. So we just take the natural electrons that are coming in from the environmental scenes, and we display that as thermal, as a thermal register, if you will. So we take, and every temperature gradient that we see, we apply a color schema to, or a way to visualize that. So that's why our images come across as grayscale, and we're truly passive and another form of camera. The reason thermal imaging is becoming more and more important is it's sort of a sad statistic. 76% of traffic pedestrian fatalities occur at night. And those are increasing over the last 10 years. They're not going down. So pedestrian fatalities are not going down. And we're seeing governments around the world now starting to look at how are we going to improve safety for the pedestrian. They've been focused so much on occupant safety in a vehicle, but vehicle pedestrian safety has not been the domain of government regulation. So even in the new infrastructure bill that was passed by the Obama administration recently, there are mandates that we are going to fix pedestrian safety. And so the National Highway Transportation Board, NHTSA, and governments around the world have come out with new nighttime safety tests. So interestingly, a few months ago, the IIHS ran a test of current production vehicles where they tried to apply the new testing criteria, which is turning off the lights, if you will, the ambient lights in the scene, having pedestrians crossing the road with oncoming headlights, and running those two tests. Of the 23 vehicles that they tested, only one passed. Only one successfully stopped and did not hit the test dummy. So government regulations are absolutely coming on to address pedestrian safety. Scenarios are not straightforward for cameras and radars together to actively brake when those scenes are coming on. And so we're seeing a lot of interest now from OEMs looking at other modalities that can see completely at night. It's a fair question. A lot of people are trying to say, can we use high dynamic range cameras? Can we do more better points on target with radar, 4D radar? The reality is that you're going to need all of these sensors in order to make it purely safe, to get to this goal of zero fatalities in the 2030s that some of the OEMs have been espousing. You're not going to be able to do it just with the current sensors. You're going to need sensors that can see in complete darkness, and those type of modalities just simply don't work. And the problem has always been the cost. Can we get thermal sensors down to be cost effective enough to be put into vehicles? And with the technology that Owl's bringing to market, which is a focal plane array designed for high resolution imaging, we know that we can get into that few $100 price point or less that's required to bring thermal as a camera that will be used across all of vehicle production in the next few years. I would jokingly say there's been some bad marketing around thermal imaging, and I don't say that lightly. I think back to LiDAR 7-8 years ago. I started first coming to AutoSens. We were really evangelizing the use of LiDAR when people said, oh my gosh, it's way too expensive. Velodyne had their $64,000 spinner out there, and everybody got enamored with LiDAR a lot because that was what Google was doing at the time, now known as Waymo. They were advocating the use of LiDAR, and it was starting to become wow, I need to be involved with LiDAR if I'm going to be a participant in autonomous driving. I think what is going to happen now is that we realize that we would put the collective energy of an entire industry to cost reduce, address the reliability of LiDAR systems. Look, we generated 64 different LiDAR companies, billions of dollars in investment, and created that market really from the ground up. And thermal has faced similar problems. Thermal has been viewed as too expensive. It hadn't had a big ecosystem, but that's all changing. The costs have come down dramatically. It's a simpler ecosystem to create because it rides on the camera ecosystem, similar lensing technologies, and it's just a matter of proving that the technology works, bringing the cost down, and I think it'll be a much simpler and more rapid adoption than that was of LiDAR. So we've learned a lot in the industry on how to bring this new technology out, and I think you'll see it happening for sure.